In this video, I'm going to go over the notation for ANOVA. You're going to notice a lot of new symbols, but don't be daunted. This is just new. It's not that it's inordinately hard. You will get used to them, but just know that it will be a matter of taking some good notes in this video. Think of the notation for ANOVA like the notation for a beautiful symphony. It helps us put it all together. Let's take a look. So we have notation that we're going to talk about. I'm going to show you some formulas and how we apply these concepts. So this is a data table, and I've posted one of these data tables right above this video. I highly recommend that you either print out these data tables as you're working or you recreate them on paper and fill them out by hand. It really helps you in solving the ANOVA, and in fact, everything you need to calculate an ANOVA is on this data table. So, notation and formulas. First of all, K is used to identify the number of treatment conditions. Now, K and conditions start with the same sound, so that might be how you can remember that the letter K means the number of treatment conditions. So in this case, we have K equals 3 because we have 3 different groups. And a lowercase n represents the number of scores in each treatment condition. So however many people are in each treatment condition, that's the n, lowercase. Capital N is the total number of scores in the experiment or study. It's adding all of the people up together. T is the sum of all the scores for each treatment condition. So this is the treatment total. So each group will have a treatment total by adding up all the values of the scores. G is going to be the sum of all of the scores in the study, the grand total. And you can find that grand total by just summing up all the individual treatment totals for each group. Sums of squares is not new, but we're going to use a different calculation for the sums of squares total. And M, the mean is not new, but just a reminder that each treatment condition has its own mean. So this is what it looks like. Don't be daunted. Here we go. So this is the first group, treatment number 1. It has 5 different scores. And T, remember, is adding up the total of all of these scores. So 0 plus 1 plus 3 plus 1 plus 0 equals 5. The treatment total for the second group, 4 plus 3 is 7, plus 6 is 13, 16, and 20. So the T is adding up all of these numbers, adding them up. Not counting them, but adding them up. The sums of squares is just found by taking each score, subtracting the mean, squaring that deviation score, and adding them up, just like we've done a million times before. That's the sums of squares, and we calculate it for each individual group. Each group has its own sums of squares. The lowercase n is the number of people or the number of cases in each group. So we have 5 in each group, so we have 5, 5, and 5. And finally, I notated the means for each group. So if you take these 5 scores, the mean is 1. These 5 scores, the mean is 4. And these 5 scores have a mean of 1. Pretty simple so far. Now, this is a number that we're going to need when we're doing our sums of squares total. Way back in week 3 of this class, I introduced you to the definitional form or formula for finding variance, and sums of squares. However, there was another formula called the computational formula, and we're actually going to use that. And to use the computational formula, we do need this sum of every score squared. So that's there just because we need it. We have the G, which is that grand total of adding up all the treatments together. The N is adding up all the smaller n's together to come up with the big N of 15. And remember, K is the number of our conditions, 1, 2, 3, 3 groups. So to do an ANOVA, we're doing 9 calculations, but don't be daunted, like I said. It's all very logical. It proceeds in a certain way. We're going to need 3 values for sums of squares. We need 3 values for degrees of freedom. We need 2 variances, one for between scores variance and one for within variance. And then finally, we find the F-score. So it's totally doable, I promise you. So we need to compute 3 sums of squares and 3 degrees of freedom. For each of those, we have total, between, and within. We're going to compute the sums of squares for the total study and we're going to put it into two components, between sums of squares and within sums of squares. And we'll do the same for the degrees of freedom. We're going to compute the degrees of freedom for the total study, but then we'll look at it for between degrees of freedom and within degrees of freedom. And this is what our sums of squares formula looks like. This is probably the newest thing that you're going to be exposed to, and maybe the thing that it's not hard, but it's just going to require a little bit more thought. To find the sums of squares total, we're going to sum up every squared score. So we take every score in the group and we square it. And then we minus what's on this side, the grand total of the scores squared divided by n. So that's what we're going to do. So we do this first, and then we do this next piece, and then we subtract. So that's the last thing we're going to do, is the subtraction. And this is going to help us find the sums of squares within and the sums of squares between. Okay, in the next video, we're going to work on some of those calculations.